In Android development, whenever we work with listeners or receivers, we always have to think about registering and unregistering them properly. A very common example is a broadcast receiver. If we register a receiver but forget to unregister it, it can continue to live longer than expected. This leads to memory leaks, unexpected callbacks, and sometimes even app crashes. Earlier, when we were using activities or fragments, we handled this using lifecycle callbacks. We used to register listeners in onStart or onResume and unregister them in onStop or onPause. This ensured that listeners was active only when the screen was active and cleaned up correctly when the screen went away. With Jetpack Compose, things are little different. Composable don't have on start or on pause. Instead, they have their own life cycle based on composition. So the question becomes, how do we safely register and unregister listeners inside a composable without causing a memory leak? This is where disposable effect comes in. Disposable effect allows us to run some logic when a composable enters the composition and cleans it up when the composable leaves the composition. In simple terms, it helps us to register and unregister listeners within the lifecycle scope of a composable. Let us switch to Android Studio and look at a code example. In this example, I want to listen to airplane mode changes using a broadcast receiver. Here I am getting the current context using local context.current. Then instead of using this context directly, I extract the application context from it. This is important because when we register things like broadcast receivers or listeners, we want to avoid accidentally holding a reference to an activity context. Now I create a state variable called is airplane mode on. This state represents whether the airplane mode is currently enabled. Whenever this value changes, Compose will automatically update the UI. Next, I create a broadcast receiver. Notice that the receiver is wrapped inside a remember. This is very important because recomposition can happen multiple times. Using remember ensures that the same receiver instance is reused instead of creating a new one on every recomposition. Without this, we could accidentally register multiple receivers, which again could lead to memory leaks. Inside onReceive, I check whether airplane mode is enabled or not. Based on the value, I update the Ease Airplane Mode on state. Since this is a compose state, the UI reacts automatically. Now comes the most important part. I use disposable effect with unit as the key. This means that the effect runs once when the composable enters the composition. Inside this block, I register the broadcast receiver. At this point, the receiver is active and listening for system changes. Inside the onDispose block, I unregister the receiver. This code runs automatically when the composable leaves the composition. This is crucial because unregistering the receiver here prevents memory leaks and unwanted callbacks. You can think of onDispose as a compose equivalent of onStop or onDestroy. Finally, based on the Ease Airplane Mode on state, I display either Airplane Mode on or Airplane Mode off on the screen. Whenever the system settings changes, the receiver updates the state and the compose updates the UI automatically. Now let's run the app and see this in action. When the app launches for the first time, we can see that airplane mode is off. This matches the current system state of the emulator. Now I will turn the airplane mode on from the emulator settings. As soon as the system broadcasts the change, our broadcast receiver is triggered and the UI updates automatically. We can now see the text change to airplane mode on. This confirms that our receiver is working correctly and is reacting to system events in real time. Now let's take a look at the logs. Here we can see the message broadcast receiver registered, which tells that receiver was registered and when the composable enters the composition. Now I press back and now we can see that broadcast receiver is unregistered. This proves that DisposableEffect handles both setup and cleanup automatically and ensures that we don't leak any listeners when the composable is removed. To summarize, DisposableEffect is used for setup and cleanup logic in Jetpack Compose. It runs when a composable enters the composition, and the onDispose block runs when the composable leaves the composition. This is extremely important because it helps prevent memory leaks, especially when working with listeners or system resources. DisposableEffect also scopes registration and unregistration to the lifecycle of the composable, not the activity or fragment. Because of this, it is ideal for things like broadcast receivers, listeners, callbacks, and observers. The most important takeaway is this: if you register a listener in Compose, you must unregister it to avoid memory leaks. And the DisposableEffect is the correct API to safely handle that within the composable lifecycle. Thanks for watching. If you have any questions about DisposableEffect or Compose side effects, drop them in comments. See you in the next video.